guys, as you can see over here, we have the LED and this is the slide potentiometer. Now what I do is that I move the knob of this potentiometer. See, the LED starts to go bright, and when I reach the maximum to the left, it is the brightest. Now if I go in the opposite direction, it start to go dimmer and dimmer. It is the dimmest here. Now it will go brighter or dimmer, depends upon where on the potentiometer this knob is. See, it's here, then it will remain here. Now let me show you the code. So this over here is the code. You can see that we are just initializing an ADC pin to read the potentiometer. We initialize the PWM pin at 5K hertz rate. Then we read the pin for the potentiometer value. Then we started the PWM. Then we mapped the ADC value to the PWM equivalent duty bits. Then we just gave the duty cycle directly using the same variable which is receiving the value from the potentiometer is also the duty cycle to the PWM module. So in this way, this gives us this result. Hello guys, welcome to learning microcontrollers. In this lecture, I am going to show you how we can use a slide potentiometer to control the brightness of an LED using PIC16F877A's generated PWM, that is pulse width modulation. So let's get started. So guys, this over here is a slide potentiometer. As you can see, there are of various shapes and sizes and models in the market. I'm going to use this one. It's a 10K slide potentiometer. It is easily available in the market. As you can see, it have like 6 pins at the back, 1, 2, 3, 4, 5, 6, 4 at this side, 2 at this side. Now guys, this over here is a PIC16F877A microcontroller having 40 pins. It's a DIP version. This on the left is a slide potentiometer, and as you can see, we have 6 pins, 4 at the top, 2 at the bottom. Now the bottom right pin is our VCC. The top rightmost pin is the ground. The second from the right from the top, if you hold it like this, is the ADC pin. Rest of the 3 pins will go empty. You do not need to connect them. Now guys, for the ground pin, connected directly to the ground of your PIC16F877A like this. For the VCC, connected to the VCC of your PIC16F877A like this. For the ADC pin, you can connect it to any available ADC pin of your PIC. I'm going to use a pin number A0. Now guys, this over here is a 5 mm crystal type LED whose brightness we will control using this slide potentiometer using our PIC16F877A. As you can see, this LED have 2 pins, one longer, one shorter, but the problem is that this LED requires like very little current to operate, and there is a possibility that PIC may get it burned by giving more current than the required. So to make sure that it never gets burned, we use a protection resistor. This safety resistor will limit the current going to the LED from the PIC. So this can be of any value from 100 to as many high you may require. I'm going to use a 220 ohm resistor because higher the value of the resistor, the dimmer the LED will go. So 220 is an ideal value. Now guys, let's do the connections. The longer pin, the shorter pin is the ground and the longer pin is the power like this. Now guys, you connect the longer pin to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor, you will take out your output. So your output will go to only 2 pins if you want to use a PWM. There are only 2 pins, that is C2, which is a PWM 1 pin, and C1, which is a PWM 2 pin. So I think PWM 2 is C1 or C3, but whatever it is, we are going to use a PWM 1, that is C2. So if you want to use the PWM, then you have to go either the PWM 1 pin, that is the CCP1 or CCP2 on the data sheet. You cannot use the PWM on any other pin as well. Now guys, for the ground pin, connected to the ground of the PIC like this. In this way, our connections are completed. Now we can move on to the hardware. Let me introduce you to the hardware before we move on to the programming. So guys, this over here is the hardware. This is our slide potentiometer. Wiring is as shown in the presentation. The 2 rightmost pins are connected on the top and 1 right pin on the bottom, purple one, brown and the white. And here we have LEDs. So we are going to use this LED only out of this module, this LED, and it is connected to the pin number 17, that is C2, which is the PWM pin of the PIC. And the rest is as shown in the presentation. Rest is just a trainer board here, so don't get confused. And these are only of our concern here. So let's move on to the programming. So guys, this over here is the MikroC for PIC. The version I am going to use is 7.6.0. You can use the higher version as well. I also have a video on this as well. Please go through that video in which I have shown you how you can download and install this MikroC for PIC latest version from official website, free and totally legal. Click on File, New project. This window pops up, click on next, write the name of the project. I am going to write PWM brightness LED tutorial slide pot, also add that by LM. So, this is the name I wrote. You can write any name you prefer. Now guys, this is the path where your files will be created, hex file, and this is the controller you are going to use. I am going to use a PIC16F877A. The crystal I have connected to the pin number 13 and 14 of PIC16F877A is 20 megahertz. So, I write 20 here. Now, click on next and finish. Now guys, before you do anything else, first of all click on this save button to save your work. This window pops up, save it wherever you prefer. Now guys, first of all, we have a potentiometer which requires an ADC pin to give data. So, go to the right in the library manager, go to the MikroC libraries, expand it, expand the system libraries. Here the first one is the ADC, check mark this library and expand it, and here you have this ADC I90 command, double click on it. This window pops up and this is the command in the example ADC I90, copy it. This command initialize all the ADC pin of your PIC16F877A microcontroller. So, we initialize all the pins, give some initialization delay, and I give a delay of 100. That is fine. Now guys, for the PWM, I told you, you cannot connect your LED to any pin you prefer if you want to use a PWM pins. Now for the PWM, as you can see the data sheet, in the data sheet there are CCP2 and CCP1 pin. So only RC1 and RC2 support the PWM. CCP1 pin is the pin number 17 on which our LED is connected. So it is the PWM1 pin. Now let's go back. Okay, now to initialize the PWM pin, go to this PWM library here, check mark this, expand this. Here you have this command PWM1 I90, double click on it, and here you have this command, copy it, paste it here. Now this command initializes the pin number 17, that is the PWM1 pin with a PWM frequency of 5000, that is 5 kilohertz. So you can change this frequency if you want any other frequency, but for our application it's fine. Now give some initialization delay, not necessary, but I always suggest you give it in the one time loop. Now for the LED we have the PWM initialized, for the ADC we have the ADC pin initialized, for the potentiometer this is for the potentiometer, this is for the LED. So we don't have anything else. Now we move on to the forever loop. Write down while one, forever loop starts here, ends here, and inside the forever loop first of all we read the value coming from the potentiometer. So go to the right, in the ADC library you have this command ADC read, double click on it. This window pops up, this is the command syntax, copy it, paste it. Now this command over here, this is the variable in which the data will be stored coming from the ADC pin, and this is the syntax, and this is the channel. The channel we are using is 0 because I have connected the potentiometer output pin to the pin number A0. So it means channel 0. If it was A1, it will be 1. If it's A2, it will be 2. So it depends upon which pin you are using. Now this is the variable. So we initialize an integer. You can use a float, integer, short, whatever you prefer. I'm going to use an integer. So I write here pot, that is a potentiometer value. So this variable will store the value coming from the potentiometer. Now guys, the next thing is we want to control the brightness of an LED. So for that we will need to use the PWM library. Also give some initialization delay here, not necessary, but I always suggest you give it for good programming practice. Now go to the right, go to the PWM library. Now we start the PWM, double click on this PWM1 start command, double click on this. Okay, here you go. This is the command, it will start the PWM1, else your PWM will not work. So PWM1 starts here. Now the next thing is the PWM has started. We need to set the duty cycle. This is the PWM1 set duty. So duty cycle will decide how bright our LED is gonna glow. So this is the set duty. Oh sorry, I forgot to copy it. Not 2, only 1. We are using the PWM1 pin. So this is the command PWM1 set duty, this one. Now see over here what it says. PWM1, this is set duty. This command sets PWM duty ratio. Parameter duty takes value from 0 to 255. Now this is of concern, where 0 is 0%, 127 is 50%, 255 is 100%. This means 0 means it will be that LED will be off, 255 means it will be at maximum brightness, and 127 means it's at 50% brightness. So that's how we are going to control the brightness of an LED using the duty ratio. Now other specific values for duty ratio can be calculated using this formula. Okay, that's fine. Now what is the problem? Problem is that our ADC is 10 bit. ADC is 10 bit, meaning 2 power 10 equals to 1024. So, now this is the case. Here our duty cycle is maximum 0 to duty 8 bit, not 10, it is 8 bit, means 2 power 8 equals to 256. Now, we have to map this, whatever the value comes will go above the 256. So, we need to divide this by a suitable number, which will make sure that the brightness, these values always remain within the scope of this 8 bit data, 8 bit duty cycle. Now, I tell you how to do it. Now, open the calculator where you have the calculator. Okay, let me open the calculator. Okay, here we go. Now, on the calculator, write down 1024, that is 2 power 10 divided by 256, that is our. So, 4 is a digit, whatever the value is coming from the this potentiometer, I write here pot is equal to pot divided by 4. Now, whatever the value is coming from the potentiometer will be divided by 4 before being fed as a duty cycle. Now, go back to the PWM1 set duty command. Here you have this command, this PWM1 set duty. You copy this command over here, and inside it, instead of going this, just write this. This is our duty. Our duty is whatever is coming from the potentiometer. So, that's great. Give some initialization here, a delay here, and now this is it. This is simple as that. If you want this to be a bit slower, you can add a delay here. I will not add a delay here. So, this is the code. What we are doing is that we are reading value from the potentiometer, then we start the PWM, then we map the value within the range of our 8 bit PWM, and then we just set the duty cycle from the potentiometer's value. That is all. So, let us build this code. Press this button to build it. Okay, it is built without any errors. Go to the PIC16 programmer tool. I have a video on this, how you can download and install this PIC16 programmer tool as well. Please go to that as well. Okay, there select the device PIC16F877A. Okay, PIC16 is disconnected. Let me reconnect it. Okay, restart the program. Sometimes it happens because it is opened since hours. Okay, guys, here it started up. So, let me open it. So, select a device PIC16F877A is the one I am choosing. Click on file, import hex file. This is the file we just created. I click on write. Okay, the new file is being written. I also have a video on this programmer tool. Please go through that to see how to download and install it. So, this is the hardware. Let me zoom out so you guys can see better. So, the circuit is powered up using this PIC16 programmer tool. So, we have some brightness of an LED. So, I now move this pot. See, it is getting brighter, brighter and brighter. See, it goes brightest at this point. Now, if I go in the opposite direction, see, it start to go dimmer, 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 and turns off. See, this is how it's gonna work. Now, when I move this, see where I stopped it remains at that brightness. See, I move it further, it goes brighter and brighter. Now, I move it in the opposite direction, it starts to go lower down. See, now it's the dimmest. Now, if I go in the opposite direction, it will start to get brighter, 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 and at the maximum, it is the brightest. See, this is how this is gonna work. So, guys, this is it. Thank you very much for your time. I hope you guys learned something from this lecture. We'll see you in the next lecture. Goodbye until then.